Welcome back in lecture series on topic chemical thermodynamics. And today we will discuss about enthalpies of physical transformation. Physical transformation means physical changes. And during physical change, heat is either evolved or absorbed. And that is called as a enthalpies of physical transformation. Now, physical transformations are of different types. That is, first, phase transition. Phase transition means one phase of a substance is converted into another phase without change in chemical composition. That means a state of matter is changed from one state to another state. For example, fusion means solid is converted into liquid, then it is called as a fusion or it is called as a melting. Or vaporization, when liquid is converted into gaseous state, it is called as a vaporization. Or when solid gets directly converted into gaseous state, it is called as a sublimation. And in all these phase transitions, these are phase transition, state of a system is changed. State of substance is or state of matter is changed. And here in all these changes, either heat is evolved or absorbed. And that is called as the enthalpy of phase transition. We will define it later on, but that is called as the enthalpy of fusion, vaporization or sublimation. Second type of physical change, that is atomic or molecular changes. That are of two types, ionization and atomization. And third physical change, that is when any substance solute is dissolved in a solvent or any substance is dissolved in a particular amount of solvent, then either heat is evolved or absorbed. This is also a physical change, and during this some amount of heat is absorbed or evolved, and that is called as the enthalpy of solution. We will see one by one. So when solid, liquid or gas, these are the three main states of matter. Plasma is also there, but these are the three main states of matter, and when these three states of matter changes from one state to another state, then some heat changes takes place. That are called as a enthalpies of phase transition. For example, solid is converted into liquid, that is called as a melting or fusion. Here liquid is converted into gas, that is called as a vaporization or evaporation. Gas is converted into liquid, that is called as a condensation. Or the solid is converted into gas, that is called as a sublimation. So these are interconvergence of states of matter, and during this some heat changes takes place. And enthalpy is the heat change takes place at constant pressure. So enthalpy of phase transition means enthalpy is a state function. So enthalpy of phase transition means one phase of a substance is converted into another phase at constant temperature. That means process is isothermal. Temperature remain constant and pressure without change in chemical composition. That is the enthalpy of phase transition. And remember here that phase transitions are reversible at constant pressure and constant temperature. And at that time, both phases, when phase transition takes place, then both phases are present. That means both phases exist at equilibrium, and equilibrium is attained. So here solid is in equilibrium with its liquid. Solid when gets converted into liquid, then that process is called as fusion, and reverse of this is freezing. Like that liquid is converted into gas, that is called as a vaporization, and reverse of that is called as a condensation. Solid is converted into gas, that is called as a sublimation, but reverse of this is called as a deposition. So here one phase of a substance is converted into another phase at constant temperature and pressure without change in chemical composition is nothing but a phase transition. Now, in general, the definition of phase transition is like this. You can use this definition to define any type of phase transition. So, enthalpy change that occurs in process Here process means fusion, vaporization or sublimation. Of 1 mole, 1 mole is most important. 1 mole enthalpy is considered for 1 mole. So enthalpy change that occurs in a process of 1 mole of a substance without any change in temperature at constant pressure. That means temperature remains constant at constant pressure is called as a enthalpy of phase transition. So using this definition, you can write definition of enthalpy of fusion, vaporization or sublimation. How that we will see here. The enthalpy of fusion means enthalpy change that occurs when 1 mole of a solid is converted into liquid without change in temperature at constant pressure is called as a enthalpy of fusion, and it is denoted like this. Remember that delta fuse, F-U-S-H, H for enthalpy, delta P for change in enthalpy. That is enthalpy of product minus enthalpy of reactant, or enthalpy of final state minus enthalpy of the initial state. That gives you enthalpy of fusion. So, for example, ice, solid water, that means ice, when converted into liquid water at 0 degrees Celsius, then enthalpy of fusion is plus 6.01 kilojoules per mole. This much amount of heat, that is 6.01 kilojoules, this much amount of heat, when it is absorbed, when ice absorbed, then it gets converted into liquid water. So it is an example of enthalpy of fusion. Or the enthalpy of fusion of oxygen. At 55 Kelvin it is 0.45 kilojoules, very low value is there. Or for H2S it is 2 kilojoules per mole. Now why these values are very low? Because these are molecular solid, and in molecular solid intermolecular forces of attractions are weak, and therefore they have low enthalpies. Whereas enthalpy of fusion of NaCl, enthalpy of fusion of NaCl is how much? 29. The value is very high, and this is due to what? The NaCl is ionic compound, and therefore intermolecular forces of attraction are very strong, and therefore it has a high enthalpy of fusion. So from the values of enthalpy of fusion, we can get idea that how much the forces of attraction between the constituent particles are strong or weak. So here when 1 mole, that means 18 gram of water is converted, solid water gets converted into liquid water, then how much amount of heat is absorbed? Plus 6.01 kilojoules of heat is absorbed at temperature 0 degree and pressure 1 atmosphere. So here in this graph it is shown that is energy is absorbed when solid ice gets converted into liquid state, and that is what here the phase change. The red color patch shows the phase change. Here both are present, solid is also present and liquid is also present, and the temperature, corresponding temperature is how much? 0 degree Celsius. So at 0 degree Celsius solid ice is also there and liquid water is also there, and they are in equilibrium with each other, and that is called as a phase change. And during this whatever heat change takes place, that is called as a enthalpy of fusion. So reverse of enthalpy of fusion is enthalpy of freezing. It is denoted as a delta freeze, H. So enthalpy change that occurs when 1 mole of a liquid is converted into solid. Reverse of that, 1 mole of solid converted into liquid. Instead of that, we are writing here when 1 mole of liquid is converted into solid without change in temperature at constant pressure is known as enthalpy of freezing. So example of this, that is water in a liquid state gives you water in a solid state, that is enthalpy of freezing is equal to minus, here sign is changed. Enthalpy of fusion is endothermic, whereas enthalpy of freezing, when this much amount of heat is removed from the system, then liquid water get freezes. So minus 6.01 kilojoules per mole. So this is what enthalpy of freezing of water. So here this is what the enthalpy of fusion. Solid get converted into liquid state. But when liquid gets converted into solid, then that process is called as a freezing, and delta H, that is enthalpy change of freezing, is negative therefore, as it is a reverse process. So second type, that is enthalpy of vaporization. It is indicated by like this, delta VAPH. And enthalpy change that accompanying the vaporization of 1 mole of a liquid without changing its temperature at constant pressure is enthalpy of vaporization. So here when liquid is converted into gaseous state, then at that point liquid is also there and gaseous substance is also there, and they are in equilibrium with each other, and this at this particular stage the temperature is constant, and that is called as a phase change from liquid to gas, and that process is called as a vaporization, and it is endothermic process. Heat is absorbed during this phase change. So example, that is water when converted into gaseous water, that is vapor state, then how much amount of heat is absorbed? 40.7 kilojoules. This much amount of heat is absorbed at 100 degree Celsius and at 1 atmospheric pressure. And if this same change is carried out at low temperature, that is 25 degrees Celsius, but pressure is constant, then during this the delta H, enthalpy of vaporization, is plus 44 kilojoules per mole. And if this change is carried out at 0 degrees Celsius, then enthalpy of vaporization is how much? Plus 45.07 kilojoules per mole. So see here, if you decrease the temperature from 100 to 0 degrees Celsius, then enthalpy change, enthalpy of vaporization increases. As temperature is decreased, more amount of heat is required to convert liquid water into gaseous water. So enthalpy of vaporization is more, and the reverse of vaporization is condensation. See here, liquid water when it converted into gaseous water, then that process is called as a vaporization, and delta H is positive. And when the gas get condensed and converted into liquid, that process is called as a condensation, and delta H is negative. So enthalpy of condensation of water is at 100 degrees Celsius, it is equal to how much? Minus 40.7 kilojoules, whereas at 25 degrees Celsius it is 44 kilojoules minus, and here at 0 degrees Celsius it is equal to minus 45.07 kilojoules per mole. So condensation, definition of enthalpy of condensation is what? Here it is denoted by delta CONH, CON for condensation. So enthalpy change that accompanying the condensation of 1 mole of a liquid without changing its temperature at constant pressure is known as enthalpy of condensation. So enthalpy of condensation of water, that is gaseous water, when condensed into liquid water at 100 degrees Celsius, enthalpy of condensation is equal to how much? Minus 40. Sign is changed. It is exothermic process. Heat is evolved. This much amount of heat is evolved during conversion of gaseous water into 1 mole of gaseous water into 1 mole of liquid water. So here this is condensation, and condensation is a negative. Enthalpy change is negative, and condensation is a reverse of vaporization. So third, that is enthalpy of sublimation. Fourth, third, enthalpy of sublimation. So enthalpy change for the conversion of 1 mole of a solid directly into vapor at constant temperature and at constant pressure is known as enthalpy of sublimation. It is denoted like this, delta SUBH. That is the enthalpy of sublimation. Example of this, water in a solid state when gets converted into water in a gaseous state at 0 degrees Celsius, then enthalpy of sublimation is equal to how much? 51.08 kilojoules per mole. This much amount of heat when it is absorbed, then water in a solid state gets converted into water in a gaseous state. And during this, whatever heat change takes place, that is called as the enthalpy of sublimation, as it is a sublimation process. So, sublimation means, suppose this is a solid state and this is a gaseous state, that is vapor state. Then this change can be carried out by two ways. One, that is directly solid is converted into gaseous state, and then that is called as the enthalpy of sublimation. But when you can carry out this change like this also, first solid is converted into liquid state, then that enthalpy change is called as a enthalpy of fusion, and then liquid is converted into gaseous state, that is called as a enthalpy of vaporization. So enthalpy of fusion plus enthalpy of vaporization is nothing but enthalpy of sublimation. How that we will see here, the conversion of solid to vapor takes place in two steps, just now we have studied, and fusion or melting, first that is fusion or melting of solid into liquid, and second one, that is what? Vaporization of liquid. So the enthalpy change, if you carry out by in two step or in one step, it remain same. So enthalpy change is same whether the change is carried out in single step or in two steps. So here you can carry out this change in a single step or in two step. The change is same, and therefore here the enthalpy of fusion, that is water in a solid state converted into liquid state, that is called as a enthalpy of fusion, and you know the value of this, plus 6.01 kilojoules per mole at 0 degree Celsius. And enthalpy of vaporization of water, that is water in a liquid state gets converted into water in a gaseous state, that is enthalpy of vaporization is how much? Plus 45.07 kilojoules at 0 degree Celsius. Now if you add these two, then you get what? Enthalpy of sublimation, and that is equal to how much? 51.08 kilojoules per mole. That means from this we can write this relation between enthalpy of fusion and enthalpy of vaporization, that is enthalpy of sublimation is equal to enthalpy of fusion plus enthalpy of vaporization. So here, for example, see here, enthalpy of fusion of sodium metal at 298 Kelvin is 2.6 kilojoules, whereas enthalpy of sodium metal at 298 Kelvin is 98.0 kilojoules. So if you know these two values, you can find out the enthalpy of sublimation. So you can solve the numericals based on the enthalpy of sublimation like this. So enthalpy of sublimation of sodium metal is how much? 2.6 kilojoules plus 98.0, that means 100.6 kilojoules. That is the enthalpy of sublimation of sodium metal. So if you know the enthalpy of sublimation, you can find out enthalpy of fusion or vaporization using this formula. So remember that this is very, very important, and while while giving the definition or while writing the definition of enthalpies, you must remember that three words, that is enthalpy change occurs when 1 mole of a substance is converted, that is solid. If it is fusion, then solid is converted into liquid state at constant temperature and pressure. All these points are very, very important. So once again we will revise this part, that is when solid is converted into liquid state, it is called as enthalpy of fusion. The heat changes are called as enthalpy of fusion, and when it is endothermic, and reverse of this is freezing, and it is a exothermic, the sign is negative. Here when liquid is converted into vapor state, it is called as enthalpy of vaporization, and reverse of this is condensation, and sign of the enthalpy change is negative. And when solid is converted into gaseous state, then it is called as a sublimation. And reverse of sublimation is deposition, and sign of enthalpy of deposition is negative, whereas sign of enthalpy of sublimation is positive. So thank you.